Okay, so first thing we want to do is include uh, one more namespace using Unity engine.ui. It's because we are gonna edit this planet here, this text object. We're gonna name it into rect text. So we are gonna basically deal with this component text, this script, and the rect transform. So that's why I name it rect text. So in order to do that in the script, we must use this Unity Engine UI namespace. Otherwise, you need to do it all the way, the whole name manually. Unity engine.ui.text rect text. But since we included it's showing in gray, we don't need this. We're just gonna name it public. So if we name public, save all, and back to the flying camera, click it, and as you see, we have it in inspector. So drag and drop to there, and there it is. We have it as a referential now. Okay, and next thing we want to do is a private transform, and we call this a mount. Okay, and this object, it's going to be the current transform that this flying camera is aiming at, it's following at, and this could be any of these point views here, and we also need those. So we are gonna make a new array of transform, public transform, and we are gonna call it camera point. And immediately, if we press the flying camera, we're gonna see that the size is 0, so we're gonna make it 4 and manually drag and drop each point view. Respectively. Alright, we have it now. The next thing, the last two variables, are the speed factors. So we have a private float. You can always type a private, but by default all members are private if you say otherwise in C#, so I usually omit unnecessary words. Float speed factor for the linear speeding of the camera, we're gonna see just in a second, equals to 0.5, and float angle factor equals to 10. Maybe we will see later on if it's good or bad. And this is for the spherical interpolation, for the rotation of the camera, how fast it rotates to the next object, from the current rotation to the next rotation. Alright, so the next thing we're gonna create is first in the start function we're gonna initialize some things, like the current mount we are on. It's gonna be setting up to our own transform for now. This maybe it's unneeded. And then we're gonna create our first function, a public void set random mount. Alright, so this function is gonna choose randomly one camera point, and it's gonna assign to this mount, to the current mount, to be the current mount that this camera is gonna follow. But we also wanna check that it's not gonna be always the same random. So if for example, if we are on a planet 1 and we are gonna press again a random, you don't expect to be again on planet 1, because you want a new random planet, not the old one. So the code is as following. We need a local transform just for this function. Temporarily we're gonna assign to new, to nothing. And first thing we're gonna check is routinely if the camera point array is actually having any member, if its length is greater than 0. And if it is, then the M transform, it's gonna be equal to camera point. And now we're looking for the element, which element from 0, 1, 2 or 3. So a unit has a function from the random class to choose an element. So random.range, and it's gonna be from 0 inclusive to camera point dot length exclusive. I hope you understand this. So it's gonna be a random function. It's gonna pick from 0 member to their last -1 to the length -1 member, and it's gonna assign that member to this temporal transform M. So we have M, but what if the mount was chosen and it's the same as previous one? So I'm gonna just type some comment here, check if same mount was chosen. Alright, and how are we gonna do this? So every class ultimately derives from object class. So the object class has a nice function for equality. So that is mount dot game object dot equals, and the equals is looking for another object, and this is gonna be the M game object. And if it is equals, then call the same function all over again. Alright, so it's gonna call it again the same function. It's kind of recursive function. It's gonna call it again and again, same process, choosing again M. And if this time, if M is different from the previous one, different from the mount, so it's a new planet, alright, then we have an else statement. And in else statement we say, alright, mount is okay, it's gonna be equal to M. That's okay. And one more thing, since we are here, the rect text, we're gonna set the text to the newly selected planet. It's gonna be mount dot get child 0 index and get that name. Right, file save all. So this is the function, and a little bit about this one. So we want the mount here. The mount could be this one, this one, this one, this one, or this one, and each one of these have a child. The Goldilocks is the child of the camera, the Kepler on camera point 2, and so on. So we need this member and this name to be assigned on this text, and this text is actually this one. So it's gonna rename the planet that we are on the screen. The next function it's gonna be a simple function that it's simply gonna change mounts. Public void set new mount, and as input parameter we're gonna have one of type transform, call it M, and basically we want to have what's here, the same thing. M, put it on mount, and again retext, direct text to the current mounted planet. Alright, so we have the function we want. Now let's jump to the main scripting of what the flying camera actually gonna moving, how it's gonna move. For now, save the script, and when we say that we're gonna program the camera for this project, all we wanna do is actually edit the position and the rotation of the camera. Alright, and that's gonna happen in the update function. Update, it's called about 60 frames per second. A fixed update is called 60, but that's for a mobile user. So we're gonna edit the transform position and the transform rotation of this camera this script is attached on. So to move the camera linearly, Unity has a nice function from vector3 class. It's called lerping.lerp, and the function lerp is asking for two vectors, a starting point and a wanting point, the end point, and a speed of step of speed of how fast it's gonna be, and that's our angle and speed factor. That's why they are created. Okay, so the first argument, it's gonna be the current position of the camera. Okay, where we now the camera, where the camera is, and the wanted, the endpoint, is going to be the mount position, and here it's gonna be the speed factor of 0.5. Alright, so a linear lerp means linear interpolation. So this actually what does is slowly spinning up from transform position to the mount position. At the half distance, the speed is going to be fastest, and as it moves to the mount position, the speed is gonna slowly turn to 0. If you don't want this, you can always choose the move towards function, and this is kinda with the straight line towards the target point. But I'm gonna use a lerping. It's kinda smooth for me. And for the rotation, notice that the rotation is a quaternion type, quaternion class, and the quaternion class has its own spherical linear interpolation. So to say, quaternion dot slurp, and as a previous, now it wants the current rotation, so that's transform dot rotation. It wants the mount next rotation and angle factor. So what it does is per how many angles degrees, sorry, per second, this, sorry about that mobile ringing. All right, so it's gonna rotate from the current angle the camera is, for example this, gradually over time to, let's say, this. Okay, and with what speed? With the speed of 10 degree per second. Okay, so let's for a moment save the script, and we're gonna need one more last thing in update, and that's the programming of rect text. Okay, so there is gonna be a little problem for that. This planet text here, it's moving into the space in this overlay canvas. Okay, and while it moves, it's using screen coordinates. It's moving in screen space in pixel coordinates. That's the same thing. And on the other hand, we have these planets which are in the world coordinates, and so we need to do a little math and a little conversion. But fortunately Unity has a nice utility dealing with Rect transforms. So we wanna edit basically this anchor position of X and Y. We're gonna say like this: rect text dot rect transform. We're gonna select the local rect transform on the rect text, access it. Then we need the anchor. Notice that there is also an anchor at position 3 there. We don't want this, we want the anchor at position, the first one, because it's a vector 2. Alright, we need this. And it's gonna be equal to rect transform get the class. Here it is, rect transform utility, and all we want to do is convert a world to a screen point. So the planet is in world, and we need to simply change it to the screen point and assign that screen point to this anchored position. And the update console is gonna catch the new location, the new conversion, and it's gonna dynamically move on top of the planet. Okay, so world to screen point function, and this wants a camera and a vector 3 as an input parameters. So the camera, it's gonna be our camera, And to reference to our camera, we're gonna simply say main. Why is this? Because every object in Unity, for example this flying camera, if it has a main camera tag, this here, is gonna reference to it automatically. And the next thing, now we need the planet position. And which one is that? We have the mount already. So get the planet, remember it has a 0 index, its child, and transform dot position. So that's it. We are done with scripting. Alright, we move back to Unity, and now to set a couple of things here. These buttons here are still without a calling function. So we have unclicked this flying camera, we've put it back there. Now it's time to get the function. So the first button, it's gonna pick a random planet, so obviously it's gonna be this one. And the next 4 are gonna be set new mount, and this is the Goldilocks, so it wants the first camera point view, this transform, as an enter parameter, and for the next so on and so forth, same process, just don't mistake the point views. Point view 3 and the last one. Alright, now each button knows which function with which parameter to calls upon our clicking. And one more thing as an explanation to this whole following camera flying thing I'm trying to teach you. Notice this, that the young star is rotating at this speed. So if the camera in their script is setting to variables, these factors, if they're too lower, too slower, it never gonna catch up the position it wants to follow, it wants to mount on. That's why we call the current position mount, because the camera is mounting on something. Okay, so and the young star currently is set to 3.5. I think I'm gonna set it to lower, to 2, and we are just gonna test this whole thing. Hopefully I didn't forget anything. This event system, it must be here. It dealing with the event calls for us, and we do have an event calls like this one, on click, on halt, on hover, and many others. Hopefully in other tutorials I'm gonna mention them, how to use them with scripting and so on, but for now I think we are good. Let's press the play. I'm gonna pick a random planet. Alright, the random planet, it tells us it's the Goldilocks. We want then to go to capital case 77. Alright, but we need to make this longer. It cuts off 1.7. Then we go to the lava land. Alright, here it is, and we go to the spinner, which is rotating so fastly. Alright, so the thing works as I planned, but the camera is notice that how fast camera is moving from planet to planet. If you want this to be slower, so let's just fix this thing here, okay, to be wider, to get more space for the longest name, which is Kepler K77. Okay, and the camera, if we put this speed factor to say 0.2, we will notice a difference. Okay, now watch this. We're gonna press play, and now we're gonna pick a random planet and see how smoothly it goes from here to here. Okay, this is still fast. It's still fast, but you can see the difference from 0.5 to 0.2. Okay, I guess one more time it's, I don't know, it's gonna be 0.07, even lower, where you can notice maybe see it's already slower. It doesn't catch now. The camera, it's never catching the camera point view. It's always at for a small amount, for a small angle. So 0.07 is not actually good, and even this thing is messed up. So the camera is very slow, so you need to fix this to 0.2. Play again. Well, hopefully now we're gonna maximize this. Play again and pick a random. Goldilocks, Kepler. I don't know why it's not showing the thing. So here it is. How about now? No, sorry, this is maximize. If we press Spania, Lavaland, Kepler, Goldilocks, and if you want to play with this one, with the direct text, select it. If you wanna make it on top of the planet, just play with this pivot variables here in the inspector. You're gonna have different effects. So that's it. That's all for my tutorials. Thank you for watching me. Hopefully I was useful somehow. You can use this in your aspects, in your part of the games, how the camera can move from one object to other object, or you can make even a full path of a trajectory of which the camera should follow. And again, thank you for watching, and stay tuned for my next video.